Hello and welcome back. In this video we will start looking at section 1.4, which is just all about the trig functions again. So I want to remind us of how we define the trig functions. So in the plane, we can define an angle in standard position as the initial side being along the x-axis, and the terminal side sort of being aligned from the origin to a point xy, and this angle is our angle theta. The point xy, x and y are the coordinates of this point, and we'll use those in these definitions, but also r, which is the length of this line from the origin to this point. So the formula for r is going to be given by the square root of x squared plus y squared, and this comes from this triangle. Again, this distance is going to be x, this distance is going to be y, and from a right triangle, we know that x squared plus y squared is equal to r squared. So that's where this comes from. And then we can define our sine, cosine, tangent, cosecant, secant, and tangent. So the sine is going to be y divided by r, cosine is x divided by r, and tangent is y divided by r. The cosecant, secant, and cotangent are all going to be the reciprocal of these of the corresponding fractions. So the cosecant is going to be r divided by y, secant is r divided by x, cotangent is r divided by y. So we can write these down as follows. So using this reciprocal idea, the sine is just going to be 1 over the cosecant. So if I know the sine of an angle, I can find the cosine of an angle by flipping it over. The cosine of theta is just going to be 1 over the secant of theta. The tangent is going to be 1 over the cotangent. I think that sine, cosine, and tangent are a little bit more common, so sometimes it's nice to be able to write down the less common angles in terms, or the less common trig functions in terms of the slightly more common ones. So cosecant is going to be 1 over the sine, secant is 1 over cosine, and cotangent is 1 over tangent. So this gives us like some very nice identities that we can use. So for example, if I know that sine of theta is 1/2, using the reciprocal identity, I can say that then the cosecant of theta is going to be 2 over 1, which will reduce to just 2. So that's quite nice. We do have to be a little bit careful. If the tangent of an angle is 0, I know that the cotangent of that angle is going to be 1 over tangent. But if I write that down, if I take the reciprocal of, let's say, 0 divided by 1, I get 1 divided by 0, and this doesn't exist. So in fact, 0 does not have a reciprocal, so the cotangent of an angle might not exist. So whenever we have the tangent being 0, then the cotangent at that particular angle doesn't exist. And vice versa. If a cotangent is ever 0, then I know that the tangent at that angle doesn't exist either. So even though they are reciprocals of one another, if one is 0, the other one doesn't exist. And then lastly, if we look at the secant, we can say, okay, so the secant is going to be the reciprocal of cosine, and so this means that the cosine of this angle, whatever this angle is going to happen to be -2 over root 5. Now, this textbook and MyLab doesn't necessarily like having radicals on the bottom of the fraction, so it would prefer for us to get rid of the square root of 5. This is a fairly simple process. If you have a radical just like this on the bottom of the fraction, the easiest way to get rid of it is to multiply by the square root of 5. So we will multiply both the top and the bottom by the square root of 5. Square root of 5 times the square root of 5. The reason that we're doing this is the square root of 5 times the square root of 5 is just 5, and then the top is going to be 2 times root 5. So after we simplify this, we can't forget the negative sign. If the secant is negative, then so is the cosine. Since the negative sign hangs around, it doesn't go away if we flip the fraction over. But if we rationalize the denominator, we'll get negative 2 root 5 over 5. Cool. So that's just looking at reciprocals. One thing that I really want to stress is that sometimes people use the exponent negative 1 to mean 1 over something. So for instance, like up here, I could write, let's say 1/2 to the negative 1 power is going to be 2, or 3 to the negative 1/2 is going to be 1/3. And this is treating this negative 1 as an exponent. And if we want to write this as an exponent, we can write sine of theta to the negative 1/2, and this does mean 1 over sine theta, which happens to be the cosecant. However, if you see this negative 1 inside of here, attached to the sine, not on the whole thing, this means the inverse function. So this is the sort of the opposite function than sine. It's sometimes referred to as arc sine, and we will see this eventually in this semester, but not until later. So for the moment, we don't want to put a negative 1 here. We want to put it on the outside of the whole thing if we want to take the reciprocal. This shouldn't matter too much. This is just a word of warning. So at the end of the last section, we looked at the signs of all the trig functions. And I want to go through this again. This chapter stresses this quite a lot. So when we're up here in quadrant 1, so this means we're to the right on the x-axis and we're up along the y-axis. If we're to the right, this means that x is going to be positive. And this also means that y is going to be positive. And r is always the distance from the origin to some point. So r is just going to be positive as well. Distances we will consider to be positive. So in this first quadrant, I know that sine is going to be y divided by r. So for example, the sine of any angle that happens to be in this quadrant, so for instance this angle, or this angle, or even something really close up there, or something really close down there. All of those angles, because y is positive and r is positive, that means the sine is always going to be positive up here. If we look at quadrant 2, where so x over here, we're now pointing backwards along the x-axis. So since we're behind 0, x is going to be negative now. Why? We're still above the x-axis though. We're still going up at least a little bit. So y is going to be positive, and r is also going to be positive. Why is r positive? It's a distance. Distances are always positive. So sine here, which is y divided by r, well, that's going to be positive up here as well. Again, the y is positive, r is positive. Divide two positive numbers, you get a positive number. Down here in quadrant 3, again, we're to the left, so this is where x is negative. But we're also below the x-axis now. We're going down, and down is negative. But r, because distances are positive, r is positive. So now I've got a negative number for y, and r is a positive number. And a negative divided by a positive is going to be a negative. And then lastly, we can come over here to quadrant 4, which, again, we're going to be to the right. So this is going to be positive x. We're going to be down, which is going to have negative y values. And r, since it's a distance, is always positive. So when we come back up to sine of y divided by r, a negative number divided by a positive number is still negative. And when you go through and you look at all the different combinations, so for instance, cosine is going to be x divided by r. So down here in quadrant 4, x is positive, r is positive. Or in quadrant 3, x is negative and r is positive. So we can see that if we're in quadrant 3, cosine is going to be negative because we have a negative number divided by a positive number. And this, in general, is fairly quick. You would just look to see, okay, in that quadrant, what are x, y, and r? Are they positive or negative? And you figure out which ones are used in here. Sine is going to be y divided by r. Cosine, x divided by r. Tangent, y divided by x. So you just look to see whether or not the negative signs cancel, if there are negative signs, and you can tell whether or not they're positive or negative. So let's do an example. Let's find the sine of all the following. So we've got sine of 300, cosine of 300. It's just that the 6 trig functions evaluated at 300 degrees. So let's figure out which quadrant 300 degrees is in. If we draw our little picture, so 0 degrees is going to start right here, pointing right to the right, pointing straight up. Well, this is going to be 90 degrees. Straight to the left, it's going to be 180 degrees. Straight down, this is 270 degrees. And then if we make it all the way back around, this is also going to be 360 degrees. So 300 is going to be somewhere in between here, which means that we're in quadrant 3. Sorry, that's a mistake. We're in quadrant 4. So what are our x, y, and r values? Well, we're pointing to the right, so x is positive. We're pointing down, y is negative, and r is just always positive. So sine, which is y divided by r, this is a negative number divided by a positive number, so it's going to be negative. Cosine, which is going to be x divided by r, positive divided by positive is positive. I'm going to abbreviate. The tangent is going to be y divided by x. Y is negative, x is positive. Negative divided by positive, negative. And a nice little trick is that the cosecant and sine are reciprocals of one another. So whatever this number is, it's going to be a negative number. And if you flip over a negative number, it doesn't change sign. If it's negative 2/3, it becomes negative 3/2. If it's, it doesn't matter what negative number it is, it's always going to be negative. In the same way, cosine and secant are reciprocals of one another. Sign doesn't change. So if one is positive, the other one has to be positive too. And lastly, tangent and cotangent, these are again reciprocals, and reciprocals don't change sign. So these will both be negative. So this is an example of just going through, if you're given an angle, we can figure out which quadrant we're pointing in and figure out whether or not it's going to be a positive or negative answer.